It's a feat of engineering to get water from wells more than 600 feet underground up to your faucet. As impressive as that is, it's even more impressive that the water that pours out of your tap, every single drop of it, is safe to drink, cook with, and wash with. Groundwater is the best and safest source for drinking water, but these two buildings and what happens inside them make it even safer. These are our water treatment plants, and they were built proactively when the Environmental Protection Agency and Minnesota Department of Health revised the health-based limits for radium. Red Wings water has elevated levels of radium, which is naturally present in the geologic formations underground, and our plants treat the water to achieve the lower drinking water limit. Plus, the treatment also removes iron and manganese from the water. This is the Twin Bluffs Water Treatment Plant. And this is the Charleston Crest Water Treatment Plant. Both were constructed roughly 2 decades ago. Both use the same filtration process, manganese green sand to be specific, and together can produce 7,000 gallons of potable drinking water per minute. Let's take a look inside and dive into exactly what these two plants are removing from the water and how it all works. As we already discussed briefly, there are 2 categories of substances that these plants are designed to filter out. First are radionuclides, which includes radium. Radionuclides are small particles that create radiation when they break down, not something you want to ingest in large quantities. Our plants are designed to keep all radionuclide levels lower than the safety standards put in place by the Minnesota Department of Health and the Environmental Protection Agency. The second set of substances treated at the plants are iron and manganese. Both iron and manganese will cause stains to develop on your clothes, cookware, and more. Iron stains tend to be red, while manganese stains tend to be black. But thanks to water treatment, neither should be a problem for the City of Red Wing water users. Now that you know the what is being filtered from the water, let's talk about the how. It all starts with raw water, which is pumped into the 2 water treatment facilities from 5 underground wells around the city. The first stop for water pumped from the wells is a trip through the aerator. The aerator creates small waterfalls cascading over a series of tubes. As the water splashes, contact with the air is increased and oxygen is absorbed. This helps the invisible manganese and iron in the water to become oxidized and turn into a solid, visible form. The process of aeration also removes hydrogen sulfide, which in turn reduces odor. The next stop for the water is a detention tank that tops out at 136,000 gallons, where the water will be held for about half an hour to allow the oxidation process to continue. At the end of the detention tank, potassium permanganate is added. This completes the oxidation and helps remove radionuclides. Once the water leaves the detention tank, it flows to these 20 by 20 foot filter cells, which have a 15-inch layer of anthracite, a type of coal used in water filtration, and another 15-inch layer of manganese green sand, another filtration substance. These materials have incredibly small voids in between grains, which capture the oxidized iron and manganese while allowing the clear water to flow through. Radionuclides will also stick to the oxidized manganese and get caught by the filter. Below the sand is reverse-graded gravel, a series of layers of progressively smaller gravel that allows water to continue to pass through while preventing material above from doing so. The water then flows inside hollow blocks that make up the underdrains and onto a collection pipe. The filters do eventually become plugged, at which point the material must be cleaned or backwashed. During the backwash process, water is pumped upward from the underdrains through the material, and compressed air accelerates the washing process. The water overflows into backwash troughs, removing the iron, manganese, and radionuclides that were dislodged during the backwash process. The backwash water goes into reclaim tanks, where the undesirable particles settle, creating a thin layer of sludge at the bottom and clear water above. The sludge is pumped to the wastewater treatment facility. The clear water, on the other hand, is reclaimed and pumped through the filters again, allowing up to 90% of the wash water to be recovered and achieving the plant's goal of maximum water conservation. Fully filtered water goes to a 168,000-gallon tank and then to a ground storage reservoir and pump station. From there, the water is chlorinated and fluoridated for public health before being pumped from the reservoir to the distribution system at a rate of 1,000 gallons per minute. Safe water is crucial 24/7. That's why communication between the treatment facilities and remote booster stations is conducted via fiber optic transmission, and generators provide backup power at each facility. Programmable logic controllers increase automation and reduce operator time, while a computer program allows operators to control the plant from the control room or even remotely. All of this means that the facilities can be continuously monitored. If an alarm condition occurs, operators will be automatically notified and can fix the problem even if they're not on site. The proof that our water system works is in the annual Consumer Confidence Report, which you can find on the city's website at any time. It shows that we're meeting or exceeding every standard that's been set. So go ahead, turn on the tap, grab a glass, and rest easy knowing that every sip is as safe as it is refreshing.